Hi everyone, this is our group presentation. We are from Group C. Our program is 1 BEEY S1/1. So we will present to you about passive RC low pass filter. So our lecturer name is DS Dr. Muhammad Syaril bin Yahya. So this is our group members. The first one is Tuan Amila Fadlina binti Tuan Azmi. Her matric number is B082110345. The second one is Divya Vanessa, anak perempuan Jaya Prash. Matric number is B082110148. The last one is me, Muhammad Lokman Hakim Muhammad Nur. My matric number is B082110153. First of all, we will present to you about introduction.
Hi, Assalamualaikum. My name is Tuan Amila Fatina binti Tuan Azmi. I will present about introduction. What is filter? Filter is a circuit which is used to filter the signal. That is, it will pass only required signal and avoid unwanted signal. Low pass filter. The low pass filter only allow low frequency signal from 0 Hz to its cut-off frequency (FC) point to the pass while blocking those any higher. There are two types of low pass filter, which is passive low pass filter and also active low pass filter. But for this assignment, we only discuss about a passive low pass filter. Passive filters are made up of passive components such as resistor, capacitor, and inductor, and have no amplifying element, so have no signal gain. Therefore, their output level is always less than the input. Okay, for the RC low-pass filter, passive low-pass filter is made up of a resistor connected in series with capacitor, and the output is taken across the capacitor. We also know that the capacitive reactance of a capacitor in a AC circuit is given as Xc equals to 1 divided by 2 pi Fc, where Xc is the reactance of the capacitor, F is a applied signal frequency, and C is a capacitance of the capacitor. Next, for the frequency response. Frequency response, also known as a Bode plot of a circuit, show the output to input ratio for a specific frequency range. Okay, next is a cut-off frequency. The low-pass filter a low frequency below the cut-off frequency and blocks any frequency higher than the cut-off frequency, where the cut-off frequency is calculated by Fc equal to 1 divided by 2 pi Rc. For calculate the output voltage of a passive low-pass filter at any frequency, the voltage divider rule is applied between the resistor and capacitor. So the output voltage Vout is given by this formula. Okay, last for the gain. Gain in a ratio of output voltage to input voltage is a gain equal to Vout divided by Vin. This gain is usually described in dB, which is the logarithm form of the gain, and it is given by gain dB equal to 20 log Vout divided by Vin.
Next will be procedure. Build the low-pass filter RC series circuit. If you can see, this is the function generator and this is the oscilloscope. So function generator positive will be connected to resistor and the negative will be connected to capacitor, and this is the oscilloscope, which is channel A. Channel A1 will be connected to positive resistor and channel B will be connected to ground, and this is channel A, channel A, then the second one will be connected to ground, and channel B positive will be connected to negative resistor, and then another one will be connected to ground.
The question B of procedure. Derive the transfer function H omega equal to VO omega over VI omega and explain the type of transfer function. So we know that H omega is equal to V out over V in. H omega, we know that V out is, the formula V out is AC over XC plus R multiplied by V in. So the formula V in is XC plus R over XC plus R multiply V in. So if we simplify the equation, we will get XC over XC plus R. So we know that S equal to J omega. So we will get SH equal to 1 over SC over 1 over SC plus R multiplied by SC over 1 multiply SC. So if we simplify again, we will get 1 over SC over 1 plus R SC over SC. So SC and SC we can cut because is divided and divided. So yeah, has left is 1 over 1 plus RSC. So if we want H omega, we just convert S into J omega, as we know S equal to J omega. So the formula of H omega is 1 over 1 R J omega C. So we divide to two category. So the first one is H0. H0 is equal to 1 over 1 plus R J. The omega we convert to 0 value. So J multiplied by 0 multiplied by C. So if we calculate this equation, we will get 1 over 1 and we will get 1 is equal to 1. So same as H0, H infinity, we will get 1 over 1 plus Rj infinite C. So we calculate, we will get 1 over infinity. So the last answer of H infinity is 0. So as we know, hence H0 is 1 and H infinity is 0 is equal to low pass filter. So this is the transfer function H omega.
Okay, C will be provide the zero end pole that is available for the circuit. So this is the calculation part for RC low pass filter, and this is the circuit. So for transfer function, the formula will be 1 over 1 plus JW over P. P equals to pole. So pole equals to 1 over RC. So 1 over RC equals to 1 over 330 times by 0.47 micro equals to 6.45 kilo. Okay, D equals to calculate the frequency. So to calculate the cutoff frequency, the formula will be FC equals to 1 over 2 pi RC. So 1 over 2 pi 330 times by 0.47 micro. The answer will be 1.026 kilohertz. So this is the result for the result of using multisim software, frequency 100 kilohertz. If you can see, this is the 100 hertz. If you can see, this is the 100 hertz. So the channel 2 will be 1.972 volt. So nearly, if theory means, we will get 2 volt, and if for when multisim means 1.9. So it's really very accurate for this one. This is the second example of frequency 200 hertz. This is the third example for 800 hertz, and this is the final example for 10 kilohertz.
After that, we will present to you about discussion. So the first point of discussion is a basic passive filter, which is low pass filter function is to remove unwanted signal and at the same time permitting signal to pass from one stage to another. Low pass filter also allow low frequency to pass from one stage to another. Simple low passive pass filter can be made by connecting together in a series single resistor with single capacitor. The arrangement of the input signal is applied to the series combination of resistor and capacitor, but the output is taken across the capacitor. Only the amplitude is already fixed at 2 V peaks. The variety value of frequency was used, such as from 1 kHz until 10 kHz, to obtain output voltage. The reactance of the capacitor varies inversely with frequency, while the value of resistor remains constant at the frequency change. The capacitor reactance of the capacitor will be very large compared to the resistive value of resisting during low frequency. From this simulation, it can be seen that frequency applied to the RC network increased from 1 kHz to 10 kHz. The voltage drop across the capacitor, therefore the output voltage from the circuit decreased. This is because the current flowing through the capacitor. The cut-off frequency is when the low-pass filter begins to attenuate or decrease the amplitude of the signal. The output signal is attenuated to 0.707 of the input signal value. Since the filter contains a capacitor, the phase angle of the output signal lags behind that of the input. So this is due to time taken to charge the plate of the capacitor. As a input voltage change resulting of the input voltage lagging behind that of them input signal.
At the end of this assignment, the main thing that student has learned is about passive low-pass filter. A low-pass RC filter is a filter circuit composed of a resistor and capacitor which passes through low-frequency signal while blocking high-frequency signal. To create a low-pass RC filter, the resistor is placed in series to the input signal and the capacitor is placed in parallel to the input signal. After that, student able to derive the transfer function and learn how to calculate zero and pole by using formula based on simulation circuit. Then, student be able to calculate frequency based on simulation circuit. Lastly, student learn simulate the circuit using multisim software and obtain the output and know how to vary the frequency and record the output voltage.